Okay, I'm going to kind of give an overview of some of the ideas of limits, which is a pre-calculus level version of a calculus concept. Limits is really looking at the idea of extremes, either getting really close to a certain number or going towards infinity or going towards negative infinity or something like that. So we start out and we fill out this table. Hopefully you've already done that. Main thing to notice in this specific table is that we're getting closer and closer to 2. We can't actually find the value of 2. We end up with an error, and the reason is we have a denominator issue where we would be dividing by 0. So we have a rational function, meaning it's a polynomial divided by a polynomial. We can't have 0 in the denominator, so we find out that x can't be 2. So what we're doing is we're investigating, we're getting closer and closer and closer to 2 without graphing. Okay, so here we've started at 1, and then we went to 1.5, 1.8, 1.9, 1.95, 1.99, 1.999. Now some people want to say this is getting closer and closer to like 7,000 or something like that. But try putting in 1.99999 and just keep adding 9s. And you're going to find that ultimately, as we get closer to 2, we start going towards negative infinity. Okay? Now, similarly, as we come in from the positive side towards 2, we go from 3, 2.5, 2.2, 2.1, etc. If we got to 2.001, 2.00001, 2.00001, we'd find that this one's growing and it's going towards positive infinity. So if we actually thought about the graph as we got closer and closer to 2, we know 2 is undefined. So there we have what I'm going to assume is a vertical asymptote. And then what's happening is if we come in from the left side towards the negative, it's falling, so something like this. And as we come in from the right side, it's rising like so. So it appears that we have a vertical asymptote. Now, you can see in my description here, if you're looking at the answers, we've kind of talked about each of those ideas. Now, ultimately, the part that's probably the newest to you is the idea of a limit. Okay, you get progressively closer to a particular value. We're trying to examine what happens. So, as x approaches 2 from the left side, or from the negative side, we're going towards negative infinity. So the idea is the limit, meaning as you're getting really close, as x approaches 2 from the negative side, that little negative indicates from the negative side or from the left, moving right, we're getting closer and closer to that number 2. Y, f of x, y is going towards negative infinity. Okay. Similarly, as we go from the right, as x approaches 2 from the positive side, y is going towards positive infinity. Okay. So the words that we see here, all of those words are equivalent to that statement mathematically. So as we move on here, we have a little bit of a long division. Okay, so I've just rewritten that fraction as a whole number plus the remainder fraction. So this can be rewritten as this. All right. Ultimately, that lets us know that it's 3 plus this extra fraction of 3. Now, a couple things I want to stress here. Your calculator does not know any better. I do not want to see 6e negative 4 written in a table. That means 6 times 10 to the negative 4th, or 0.0006. That would be my best answer. 6 times 10 to the negative 4 is okay. 6e negative 4 is not mathematical. That's what your calculator does. It doesn't know any better. We do. Now, when the value of the fraction seems as x approaches infinity, as x goes towards infinity, that means we're going this direction. Y seems to be getting closer and closer, it looks like to me, to 0. Okay? Using the same idea, we can find that actually any bottom heavy fraction, meaning when the degree of the bottom is bigger than the degree of the top, any bottom heavy fraction is going to do the same thing, because that denominator is going to grow faster, and ultimately you're going to be dividing by a larger and larger and larger and larger number, and that is going to go towards 0. Okay, so with that in mind, we can take our earlier idea of limits. We can say as x goes towards infinity, y, and keep in mind that was our earlier function, and that earlier function we rewrote as 3 plus 7 over x minus 2. So as we have a bottom heavy fraction, which is right here, that part we just learned is going to go towards 0. So any bottom heavy fraction goes towards 0, and ultimately this would be 3 plus 0, or 3. So that tells us that since we're looking at y, that y equals 3 is ultimately going to be a horizontal asymptote. Okay, so we call a lot of these things called end behavior asymptotes. Horizontals could be a slant asymptote, literally an asymptote that runs at an angle. Okay, you can actually have asymptotes that the curve starts follow, or the other curve starts following a different curve, like a parabola at the end. So you can have a lot of different things going on. So the idea is to use long division to help us. So on number 11, you can see that I'm thinking 2x times what gives me 5x squared. Well, I actually have to think 2x times 5 halves x gives me 5x squared. I multiply and I subtract my normal long division. I end up with this as my answer. Okay, so notice once again, as x goes towards infinity, the result of that can be rewritten as this plus that fraction. But that bottom heavy fraction, as x goes towards infinity, that part right there is going to go towards 0. So I have the slant asymptote y equal 5 halves x plus 2. So that's actually the equation of the line. So if you graph this function g of x under y1 on your calculator, I'd recommend that you do that. And then graph the slant asymptote under y2 on your calculator. And if you kind of zoom out or change your window to get where you're going further and further out, instead of negative 10 to 10, you might go negative 20 to 20, negative 30 to 30, okay? Or literally use the zoom out function on your calculator. You can then ultimately see a graph that looks something like this, and this is our 5 halves x plus 2. And so our final investigation, we are doing basically filling out the table just like before. Okay, and you'll notice this one's a little different in that we seem to be getting closer and closer to the same number. It looks specifically like that number could be negative 7, but we know at negative 5 it's undefined because it's 0 in the denominator. So it seems to be a whole, literally. The y value seems to be approaching negative 7 here and getting closer towards negative 7 here. So they're going towards the same y value rather than like negative infinity and infinity. And therefore, we end up going towards negative 7 on both ends as x approaches negative 5 from the negative side, as x approaches negative 5 from the positive side. Okay? And ultimately, since we have the same value, unlike before, we had infinity and negative infinity, we can actually drop the from the left and from the right part and say that as x approaches negative 5, y is approaching negative 7. Okay. So this next problem, it's actually asking you to do a little factoring and reducing, and we end up with y equal 2x plus 3 when x is not equal to negative 5 because of the domain restriction. So if you actually divide, you're going to find by long division, if you actually divide those, we get y equal 2x plus 3. So the graph of this function is exactly the same thing as the graph of y equal 2x plus 3, but we have a hole at x equal negative 5. So we literally have a line with a hole in the middle of it. So it looks something like that. Alright, finally we have some conclusion pieces. And again, I give you a summary, and this is similar to the way you would have learned it last year. Okay, but take a moment, read through, and literally you're working with division. You can kind of check your answers, and this is kind of where we're going to pick up then together as a class. Hope this helped. Should allow you to at least have a good foundation for when we talk about asymptotes and the ideas of limits.